What I want to do today, first of all, start off with looking at this idea of rationalizing the denominator. Now, I told you last year the reason we did this was because in the past, when people were asked to do questions like this, before we didn't have calculators. So what happened was that root 3 was a big long decimal that was found in this table of numbers. And imagine trying to do 1 divided by 1.73 blah 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 blah. Okay, pretty hard to do. So in order for the people in the olden days to try to figure this stuff out, what they decided to do was, instead of doing a division of decimals, let's see if we can do multiplication. So the idea was to remove the square root from the denominator and try to put it in the numerator somehow. It's much easier to divide by a number, a whole number. It's much easier to do this than the other way around. Okay? So let's take a look at this, please. Okay? So, ladies. So let's take a look at example number 3 here. And if I ask you to please simplify by rationalizing the denominator, I want you to find a way to get rid of this root 6 from the denominator. How can I do this? Multiply by what? Yeah. Now, you're going to have to multiply by root 6, because root 6 times root 6 is just regular 6. But you can't just do that to the denominator. You have to do that also to the numerator, because the expression must be equal to 1. You can't multiply by something that's different than 1, or you'll change the whole value of the expression. So when you do this, please, this is what you have. You get 10, and then 2 times 6, of course, is 12. And on the bottom, you have 2, and you have root 6 times root 6, which is just the number 6. So what's 2 times 6? That's just 12. Now, you might be thinking, well, root 12, can I simplify that? I hope you can. Can someone help me simplify root 12? 2 with root 3, thank you. And so now if you simplify this, you get the following. You get 20 root 3 over 12. And yes, of course, you can simplify 20 over 12. That becomes, what does that become? 5 over 3. Good. So 5 root 3 over 3. Okay. What I'm saying to you is these two things are equivalent. But this one down here, the 5 root 3 over root 3, is much nicer, because back in the olden days, dividing by 3, a whole number, was much easier than dividing by the root 6. So you think about it, right now in new days, we don't need to do this, but the mathematical convention is that people don't like having a square root in the denominator, and this is how you get rid of it. Okay? So for part B here, can someone suggest to me what I should do to get rid of the root 2? Times root 2, sure. So once again, multiply both the top and the bottom by root 2. And so if you do that, can you see how there's a bracket around the 8 root 3 minus 3? So please multiply that by root 2. And then, of course, root 2 times root 2 is just 2 on the denominator. So go ahead and distribute, please. 8 root 3 times root 2 is how much? 8 root 6, yep, minus 3 root 2, and I think that's all we can do. Let's stop it right there. Yes, Johnson? Tell me afterwards, okay? All right, and then for part C, it's the same idea. You want to get rid of the root, but look at this case. This one's no longer a square root. This is a cube root. So let's think about this. Can someone suggest to me what I should multiply both the top and the bottom by? 4? I want to get rid of that cube root part. Huh? A cube root of 5x? Okay. Now, don't write this down. Just watch for a sec, dear friends. If you were to take the cube root of 5x and multiply that by the cube root of 5x, what does that come to? Does it just come to 5x? No. What does this actually become? Don't write this down, just watch. If I wrote this as an exponent, that'd be the power of 1/3. Agree? Well, what's this one over here? That's also to the exponent of 1/3. Well, what do you do when the bases are the same? You add the exponents, so you get 5x to the power of 2/3. Well, 2/3 is not 1, so you still have a root here. That's bad. So what should I actually have up here? What should this be in order for this to be equal to 1? I heard it. Say it louder. 2/3. So in this case, the goal of eliminating the root, whatever it is, either the square root or the cube root, is to make it as an exponent of 1. In the case for part B, notice, and don't write this down, the root 2 was just 2 to the half. So what do I need to multiply by to give me a power of 1? Well, it's also a half. That's why I multiplied by root 2. But in this case, I don't want to multiply by the cube root of 3. I actually want to multiply by the power of 2/3, which is not the cube root of that, but this whole thing squared. So this is the correct factor, okay? I'll give you a chance to write that down to digest that, but you need the 2 there. Okay? And I'll say here as a note, the reason why this works is 5x to the power of 1/3. What you want to do is multiply by 5x to the power of 2/3 to just give you 5x. And of course, this is to the power of 1, so the root disappears. Okay. So if I do it like this now for part C, notice my numerator just becomes negative root 2, and I have this cube root of 5x all squared. We really can't simplify that because one of these is a square root, the other one is a cube root. Like I said before, the index is not the same, so you can't combine them together. But in the denominator, I think you can combine together. Well, we've got the 4, we'll keep it out there. And now the question is, what's the cube root of 5x multiplied by this? That's just 5x, right, which is what we wanted all along. We wanted to eliminate the root. And if you want to simplify this just a little bit more, I think the numerator we can't do anything about, but the denominator we can, because 4 times 5 is just 20, 20x. Okay? And that would be how you rationalize the denominator. Okay? Now, if you turn the page, I want to do a few more rationalizing questions for you, but these ones involve binomials and not monomials. Okay? So the thing that I want you to remember while we do this rationalizing of binomials is this product of a plus b times a minus b. What is this actually equal to when I distribute this? A squared minus b squared. Why is this helpful for me? Because look, the value of a gets squared. So if a was a root and I square it, its root disappears. Same thing with the b. So we're going to use this idea now to help us figure out example number 4. So example number 4 says rationalize the denominator of these radical expressions that contain binomials, okay? Binomials, 2 terms. So let's take a look at example A here. I've got a binomial of root 5 plus root 2, kind of like your A plus B. What should I multiply this by if I want to get rid of the roots? Right, use that idea and multiply by root 5 minus root 2, your A minus B. And once again, you have to do that to both the top and the bottom because you don't want to change the value of your expression. And then once again from here, just go ahead and simplify. So I will distribute the top, so I believe we just have minus 3 root 5. A negative 3 times a negative root 2 is just positive 3 root 2. And on the bottom, I'm going to ask you to distribute as well, but remember by doing it by foiling, please. So I'm going to go root 5 times root 5, and that just gives us 5. Root 5 times minus 2, that's minus root 10. And then the root 2 times 5, that's a positive root 10. And then root 2 times root 2, that's just a minus 2. And of course, we can clean this up a little bit, please. I hope you can. We'll keep the numerator as is, negative 3 root 5 plus 3 root 2. And then look what happens in the denominator. The negative root 10 and the positive root 10 disappear. So you just have a 5 take away a 2, which is a 3. If you leave it in this format, that's perfectly fine, but I think some of you noticed, hey, Mr. Lee, there's 3's all around, so why don't I just simplify that? Sure, go ahead if you want to. I'll factor a 3 from the top. And then if you want to cancel that out with the one in the bottom, that's perfectly fine to give you negative root 5 plus root 2. I'll be happy with that. Okay? Questions? No? Okay, why don't you try part B? The idea is the same. Okay, so ask yourself, what should I multiply this by to get me or get rid of that root? And since you see this is a minus b, what's your prediction that you should multiply this by? A plus b, so 4 plus the root 3 with an x. Now notice the root 3 is the only part underneath the square root, okay? Not the x, but just the root 3. You could put x in front of the root 3 if you want. So yes, Rebecca says, can I write it like this? Yes, that's perfectly fine. Doesn't make a difference. If it looks better for you, then do it that way. It's up to you. Okay? So don't forget to do the same thing to both the top and the bottom. So why don't you try this on your own quietly, please? And then if you finish this one, try C. And then D is the tricky one. So that's the honors part that I'll show you. Okay? 5 root 3 times 4. Of course, the 5 and the 4 multiply together. 5 root 3 times root 3. You could have written this as 5 root 9 with an x, but what's root 9? 3. So this is just 5 times 3, which is just 15. I will just erase that and rewrite this as 15. Okay. So note this is just 5 root 9. Okay. Now, also let's do the denominator now. We'll distribute. 4 times 4 is 16. This is 4 root 3 with an x, and this is minus 4 root 3 with an x. And of course, the last two terms, the negative times a positive means it's negative. A root 3 times a root 3 gives us 3, or a root 9. And then x times x, be careful here, you need an x squared. Okay? So if you want to simplify this, I don't think you can do much more except clean up the denominator. These, of course, just become 0, which should make sense because I don't want a root anymore. And it's 16 minus 3x squared. Done. Okay. Now, take a look at C, and I'm going to ask you to try to figure out C. What should you multiply this by? 3 root 3, yeah. Plus 5 root 2, good. So in essence, what you're doing is you're looking at the denominator and just changing the sign in between. Good. Okay, so go ahead and try this one. And then after that, try D. D is fun. I will quickly distribute this. The top, oh my goodness, lots of 3 here. 3 times 3 is 9. Root 3 times root 3, I guess you can say is root 9 if you wanted to. Then I'll say 3 times 5 is 15. 3 and 2, of course, is a 6. Then I have this one, another 15 root 6. And then the last terms, 5 times 5 is 25 with a root 4. I know some of you are thinking, Mr. Lee, why don't you simplify first? But I will try to do that in a second. The denominator, 3 root 3 times 3 root 3. That's once again a 9 root 9. Then I have a 15 root 6. But in this case now, the next one is a minus 15 root 6, which makes me feel good. Negative 5 times negative 5 is 25 root 4. Why does that make me feel good? Because these two now become 0. And you're thinking, great, no more square roots. Well, almost. What's root 9, by the way? 3. So 9 times 3 is 27. 15 root 6 plus 15 root 6. What does that become? That's right, 15 apples, 15 apples, add them together, 30 apples. Root 4 is equal to 2, so 25 times 2 is 50. On the bottom, I guess, 9, once again, 3 is 27, and this one, of course, is once again 50. So if we simplify this just a little bit more, how about 77 plus 30 root 6? And what's 27 minus 50? Negative 23. Got that? Give yourself a pat on the back. Okay. Okay, part D. So Derek, you're asking for honors stuff. This one's an honors question for this section, okay? No, you can't take back. Okay, now, ladies and gentlemen, we haven't dealt with 3 terms before, have we? We've only dealt with 2. So guess what I'd like you to do? Try to write this as 2 terms. Shh. Rebecca, please, okay? Up here. How can we change this into 2 terms to make this a binomial? Binomial is 2 terms, right? Why don't I show you a hint? Let me combine this together and make that 1 term. Here's my A. And I guess this is my B. Okay? So now if I asked you to multiply by the binomial factor, what would it be? It'd be A, and over here I had plus B. So what's the opposite? It'll be A minus B. So let's take a look at this, please. And let's see how this will help us out. Okay. So let's look at the numerator. The numerator is just a 1 multiplied by that, so no problems with the numerator. I'll just leave it as 1 plus root 2 minus root 3. But now in the denominator, this is where it gets a little bit scary. Let's distribute. A, which is the whole thing of 1 plus root 2, we're going to square it, right? This becomes 1 plus root 2 all squared. Now, I guess we can do the next part, which means taking A and multiplying it by this root 3. So I guess that's now minus, and I'll say 1 plus root 2 times root 3. Okay. So I'm just foiling right now. I hope you can follow. The next term is just these two multiplied together, so that's plus 1 plus root 2 multiplied by root 3. And then the last terms which I put together will be root 3 times negative root 3, so that's just negative root 9. Okay. Bless you. Now, you might be thinking, Mr. Lee, this still looks pretty messy. You're right. But I hope you can see that the red term and the purple term are just negatives of each other. So when I combine them together, this becomes 0. So on the top, I have 1 plus root 2 minus root 3. And on the bottom here, I think I have this 1 plus root 2 all squared. And I'm going to actually expand that out now. So I'm going to go 1 plus root 2 times 1 plus root 2. So that's this square piece. And then the root 9, of course, is just minus 3. So I'm going to try to simplify that as well. Okay. I know, Mr. Lee, you're saying there's still a square root in the denominator. I know. But at least there's only 1 now, not 2. So can someone help me expand and simplify now the denominator, please? 1 plus, was it 2 root 2? Plus 2 minus 3. Okay. Do you know why that was good, multiplying this out? What's 1 plus 2 minus 3? 0. Excellent. So now we have 1 plus root 2 minus root 3 all over 2 root 2. And have you finished rationalizing yet? No, because you still have this root 2 in the denominator. So what should I do to try to get rid of that root 2 now? Yes, I will rationalize once again. I'll say rationalize again by multiplying both the top and the bottom by root 2. And I hope you still have some room, because now I want you to take the root 2 and multiply by every single term inside here. How about root 2? What's root 2 times root 2? I guess that's root 4. Root 2 times root 3 is just root 6. And on the bottom, 2 times 2 root 2, that'd be 2 root 4. And let's just quickly simplify if we can. That'll be root 2 plus 2 minus root 6. And 2 root 4, of course, is just 4. Lovely. Tricky, a little bit, but not too bad. All right. I'm going to ask you now to take look at these last two here, and then we'll be done section 5.2. Okay? So I'll give you a chance to think about the next one on your own first. For those of you who forgot the formula for the volume of a sphere, the formula is just 4/3 pi r cubed. And if you forgot the surface area of a sphere, that's just 6s squared. S stands for the side length. All right? So I'll give you a chance to look at number 4 first. You might want to try to find the radius first, and then we'll talk about this. So you've got the volume of a sphere here, which equals to 12. So 4/3 pi r cubed equals to 12. I think you want to at least solve for r first. So I'll get rid of the 4/3, and I guess I'll be times by 3/4 on both sides. So I think that's what, 9? Don't like that pi, so I will divide by pi. Don't like that cube, so I will take the cube root. So I think r just equals to the cube root of 9 over pi. Is that good so far? Okay, good. I don't think you want to simplify that yet, so let's just leave it as is for now. If that's r, how does r relate with s? Because I want s for the surface area. Right. Notice that s is just equal to double of r. So therefore s just equals to 2 times that ugly cube root. Okay. And then, since I want to find the surface area of the cube, you told me the surface area was 6s squared. So instead of having s, I'll replace it with this now. 2 cube root of 9 over pi, all squared. Now, this is where many of you will make a mistake, okay? That square applies to everything inside this bracket. So apply it to the 2 and this cube root part. So what's 2 squared? 4. Good. Now what's the square of this root? Well, that would just be this whole thing all squared, right? Now 6 times 4 is 24. And because we're talking about rationalizing the denominator, I want you to separate this, please, into the cube root of 9 squared divided by the cube root of pi squared. Right? I can distribute that, divide. And since I don't want any square roots in the denominator, guess what you need to do here? You need to help me rationalize this denominator. Now remember, this is a cube root. You decide what you should multiply this by to make this a nice if you want a hint, remember the cube root of pi squared is the same thing as pi to the power of what fraction here? 2/3. So think to yourself, I should multiply this by what to give me pi to the power of 1? I I heard it. It's the fraction of 1/3, which becomes the, not the square root, but the cube root of pi. So to rationalize this, I would suggest you multiply by the cube root of pi. You knew that. I know. Okay, so this is the rationalizing part. Tricky. And then from here, if you can just kind of simplify and clean this up, I think I'll be very happy. What does the denominator become now? If it's the cube root of pi squared times the cube root of pi, well, the pi's can multiply together. That becomes pi cubed underneath the cube root. That just simplifies to pi, which is great. The 24 is on top. And I think now I'll just combine the radicands together because the index is the same. So this just becomes the cube root of, and 9 squared is 81 with a pi. Yeah, you can simplify cube root of 81. So what's the cube root of 81? Well, that's the same thing as 3 times 3 times 3 times 3. Oh yeah. Take that out as well. 3 cube root 3. So after all this simplification, 24 times 3 is 72. And what you have left inside is a cube root of 3 pi all over pi. Wow. So much pi. Shapes of hemispheres. I don't know if you know what a hemisphere is, but it's like half a bowl, half a sphere. Yep. And it says that there are 2 radii. They give it to you. And what they want you to do is find the ratio of the larger radius to the smaller. So whenever you're doing a ratio, you're just comparing 2 things. Compare the larger to the smaller. So I think the larger is the one on top, so I want you to compare this. The cube root of 3v over 2 pi over the cube root of v minus 1 over 4 pi. Okay? And so what you need to do with this one is you need to try to simplify this, make sure there's no radical in the denominator. And I think to help you out with this, I'm going to suggest to you to please separate them first. Okay? So let's just rewrite it as this first. The cube root of the numerator and then the cube root of the denominator. Okay? And let's make the bar like this. Okay? So please write this down. This is your first step. So all I did was I just separated the big root into 2 different parts. Okay? That's the division rule. And then because I have this complex fraction, I think I'm going to ask you to take the numerator and divide it by the denominator. Or the same thing when you do division, when I relate it to multiplication, is it becomes multiplication of the reciprocal. So if I take the numerator and this divide now just becomes multiply, I'm going to now multiply it by the reciprocal, and the reciprocal of the denominator here just becomes the cube root of 4 pi on the top and the cube root of v minus 1 on the bottom. Okay. And from here, I like you to see if you can simplify and get rid of that root in the bottom. I'll give you a chance to think about this first, but as a hint, I'd say simplify these if you can. And then you want to try to get rid of this cube root if you can. I'll give. So why make things so complicated for yourself? You've got your cube root of 3v, and that stuff in yellow just simplifies to the cube root of 2. Yes, it is inside the bracket. Now, can I simplify the stuff on the top? Notice the index is the same. So what can I do with the stuff underneath the square roots? I can put them together, and I heard someone whisper the number 6. Well, that's good. The cube root of 6v all over the cube root of v minus 1. Well, now you're almost done. Now the only thing I don't like is this v minus 1 with a cube root in the bottom. So rationalize it, very good. But what should I rationalize it with? Cube root of v minus 1, and I heard it, squared. Good. Okay. Shh, ladies, please. Okay. Math is not that crazy. Now, we are almost done because the denominator just becomes now v minus 1. That's good. Now, can we actually combine the stuff in the numerator together? The answer is maybe. Can I just point out something to you really quickly? You see this square out here? I didn't have to put it outside, right? You learned in Math 10 that I could have done something like this. Write it on the inside. Okay? It doesn't matter where you put it, inside underneath the root or outside the root, it's the same. Flower power stuff, right? Yeah, go look at my online notes. They're there for chapter 10, or Math 10, they're there. Now, do you know why I decided to do this? Because now if you look, hey, the index is the same, so what can I do with the stuff underneath? Just combine it. So therefore we have the cube root of 6 times v with a v minus 1 all squared. And look at this. Now I've got no more root. And ta-da, there's the answer.